Dear students, നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോണത് ലൈറ്റിൻ്റെ ഡിസ്പേർഷൻ ഓഫ് ലൈറ്റ് ത്രൂ പ്രിസം എന്ന് പറയുന്ന ടോപ്പിക്കാണ്. സാധാരണ നമ്മുടെ എക്സാമിന് നമുക്കൊരു രണ്ട് മാർക്കിൻ്റെ ക്വസ്റ്റ്യനായിട്ട് ചെയ്യും സാധാരണ ചോദിക്കുന്ന ഒരു സംഖ്യ. സോ അതിൻ്റെ ബേസിക് ഐഡിയ എന്ന് പറയുകയാണെങ്കിൽ തന്നെ ഫസ്റ്റ് ഓഫ് ഓൾ വി മേക്ക് prism and named A, B and C. So BC portion represents base of the prism. AB one of the face, BC base, AC second phase. So at AB we make, first we draw a normal, namely N1. Prism means it's a glass and this region is air. Air means rarer medium, glass means denser medium. So we know that when light travel from rarer medium to denser medium, the light will go, and at this position we can write as a P and Q. The medium become change. If the mediums are same, the light will go in this path. But we know that at this position there will be some change in that medium, say glass to air to glass. So it will take a deviation, air to glass deviate towards the normal. So the light deviates towards the normal. At this position we also make a normal to, and at this position PQR is light make a deviation towards away from the normal, because this is glass air and light moves from glass to air, deviate away from the normal. And the normal PQ represents incident ray, so there will be an angle, we can write I1. And this is a normal, and QR represents refracted ray, so we can write there is an angle, namely R1. We know that angle N dash QP must be is equal to angle NQ M is equal to I1. But angle NQM is equal to angle N2QR plus angle RQM. Angle NQM is equal to I1. Angle RQM is equal to R1. Therefore S2QR. So angle N2QR is equal to I1 minus R1. Okay, so we can write here angle I1 minus R. Similarly, this angle N2QR is equal to angle E2 is equal to emergent. Right. So this angle is equal to R2. Similarly, we can write E2 minus R2. This is the figure. So by using this figure, we can construct that derivation. Okay. Just imagine that. But the real ray path from this figure is from P, Q, R and S. But a man, see here with that when the light beam P, Q, R, and at this position there will be a deviation towards Q, and this position is equal to N, and here is an angle known as angle of deviation delta. Okay, this is the figure. Using this figure we can construct our derivation. It is from triangle QMR. We can write R1 plus R2 plus M is equal to 180 degree. Similarly, AQMR is a cyclic quadrilateral. Okay, so we can write a cyclic quadrilateral AQMR. Therefore, A plus M is equal to 180 degree. Equation 190 was same. So we can write A plus M R1 plus R2 plus M. Therefore, A is equal to R1 plus R2. Equation number 3. It's simple concept. Similarly, we can write from the figure NQR. Delta is an exterior angle. Therefore, we can write, consider a figure, it's an angle delta. Here I1 minus R1, E2 minus R2. Therefore, delta is equal to I1 minus R1 plus E1 minus R2. So delta is equal to I1 plus E1 minus R1 plus R2. Equation number 3. But we know A is equal to R1 plus R2. So substitute here A. So delta is equal to I1 plus E1 minus A. So delta plus A is equal to I1 plus E1. Equation number 4. Then we can write another term for minimum deviation. Delta is equal to D. R1 is equal to R2 is equal to R. E1 is equal to I1 is equal to I. Okay, so delta is equal to D, R1 is equal to R2 is equal to R, E1 is equal to I1 is equal to R1. So equation 3, R1, R2 become R1 plus R. So A is equal to R plus R is equal to 2R. R is equal to A by 2. Similarly, A plus D is equal to I plus I is equal to 2I. So I is equal to A plus D by 2. Then according to Snell's law, refractive index n is equal to sin I divided by sin R. Substitute I and R values in here. Therefore, n is equal to sin A plus D by 2 divided by sin A by 2. The famous equation. And it is very neat to solve all type of equation. Okay, it's a very important concept, and you must study it very well. Okay, with possible thinking. Thank you.